Back to BitTensor. Good to see everyone here. Thanks for coming. This has been a really interesting week. So Al and I were on the Towards Data Science podcast the other day, which was a fantastic, a really important podcast actually for data science, and hopefully we'll get some attention from that finally from the larger community. I think Al and me did pretty well. We're super excited about it. It's only our second podcast, so we're getting better at it.
Exactly, yeah.
Um, yeah, and if everyone's seen it, like if you haven't seen it, go see it. It's definitely worth watching. It's got a bit of the backstory for BitTensor, and we talk a little bit about more of the technicals with somebody that's like obviously a machine learning engineer. He talks a little bit about Aidan Gomez, which was one of the one of the writers of the Attention's All You Need paper, which a friend of ours that we worked with at 4AI when me and Ala first met to work on BitTensor, and he actually played an important role in the formation of that company. I met him in Oxford with a prototype of BitTensor, and we almost went off to found Cohere together, which now is a pretty big AI company in the space. Are a friendly collaborator or competitor, depends on how you see BitTensor in the future of AI. I think more of a collaboration potential than competition. Don't you think, Al?
Yeah, I think that's exactly right.
Mm-hmm.
It's kind of interesting that out of 4AI, two big things came out, and that's Cohere and BitTensor. So we are, in a sense, almost like sister companies.
Precisely. Or I mean, and siblings have rivalries, of course.
Yeah, I guess better said, yeah. Sister companies that refuse to acknowledge the other one exists.
Yeah. So in this chat today, we were going to talk about a couple of the technical things that BitTensor is doing.
Hmm.
Um, uh, Also, just talk about how we see the progression of this community going through what is probably going to be a bit of a bear market. Um, and our goal right now, I think, is to get a market price for Tau. And so we can, as I said at the beginning, we can build up that anti-fragile aspect of this token price. Like from humble beginnings, we're only just starting here, right? And bear markets are time for building and growing out the community and growing out our machine learning network, so that when we hit the next bull, we'll be front and center of that top 10, right in the position that Luna was in. We'll take their position. And one of the things that we're going to be doing on that route is releasing what we've called the Synapse protocol. We kind of did a sneak peek of that last week, but we actually have something to demo in this talk. But Al, maybe before we do that, is there anything else that needs to be said, like we should touch on in this call?
Not that I'm aware, no. The one thing that I kind of wanted to add in here is this timing of this bear market, I think, is actually kind of a good omen for the project, just because it's happening earlier than we had anticipated. At the same time, that means that because we haven't listed yet, when we do list, we'll hopefully be either on the exit edge of the bear market or actually at a point where we get an actual realistic listing as opposed to something that's a full-on pump and dump. So I think in a lot of ways it's kind of a blessing. So that's why, just so that the community knows, the team is rather unfazed by this whole event.
Yeah, we finished our raise like right in
Yep.
time.
Hmm.
It was, dare I say, clutch actually. Which should, and all of the funds that we sold came from mining, and they were donated by basically other members of this community that are part of the foundation right now, to fund BitTensor's trajectory through this time. And so we think that we're actually in a really good position because we have funds to grow the team over the next couple of years. It's all in cash. We're cash heavy, and the foundation is set up to carry the project with. We're hiring a new systems engineer to kind of hold the fort on some of the blockchain and other infrastructure sides of the project, and we're working with a branding agency right now and hiring front end engineers to really clean up and get our front face, clean and ready for the eventual masses. So it's awesome to be here. Probably, these are some of our last super small calls where every single one of you guys can just come into the call and make comments. You're very welcome to. Yeah. So was that it, Al? Was that the only comment you want to make?
So the only yeah, because it's just one thing to keep in mind.
Yeah. Cool.
So with that said, please take it away.
Yeah. So I'm gonna close all the coin market cap URLs I have open where I'm looking at the blood dripping down from everything, hilariously. And I have open a Jupyter notebook. I'm just going to make sure that's running and we're ready to go. So yeah, it looks like we're ready to go. Just going to share my screen here, guys. Give me a thumbs up if you can see it. Should just be the Discord channel. Yeah, we're good. Was that a thumbs up, Terrence?
Yeah.
Okay, right on. Okay, cool. So this is, I mean, just a bit of a preamble. So the way that BitTensor validation works, right, is that we measure the informational significance of tensors. Those tensors are embeddings. They're the last hidden layer of a neural network that's doing language modeling. And that's the most informationally dense layer of a neural network. It holds like general representations of language, which can be used for all sorts of different tasks. Like if you're doing sentiment analysis, that you would use those embeddings to do sentiment analysis. But BitTensor, because of the variability, or so used to like the mutability of the validators, and the fact that this validation technique allows us to measure information against a loss. That loss can be many different things. So we can expand the way that the validators are validating the miners in the system to make them more robust, to incentivize different types of machine knowledge. I mean, and we've touched base on this a couple times in the past, like for instance, moving to video instead of just text, or moving to images. All of those would be different types of testing mechanisms over top of the network, so that we can drive the system to produce more of that thing that we're wanting to produce. So Synapse is our conduit. It's like our entry point to creating that type of incentivization, to broadening what we can incentivize out of BitTensor, not just general embeddings. And there's kind of an issue with general embeddings, and is that because they're so general, they have to be decoded into something before they can be used by a downstream client. For instance, they're not directly interpretable. You actually have to apply a neural network to decode that information that comes out of BitTensor, it makes the system a little bit unwieldy. Specifically, a machine learning engineer can't really interact with BitTensor in a way that makes sense. Caro is building something like an OpenAI playground right now that works on text, but he can't do that yet without training a language model on top of BitTensor, which then runs in the cloud, and that takes away from the interactability of BitTensor. So synapses are these different entry points, and for instance, one of them is the standard entry point of embeddings. Another entry point for BitTensor that we're adding right now is the ability to produce casual LM logits. This is just a direct prediction of the next token in a sequence. So this is not it's post decoded information from the general embeddings. It tells you directly what the outputs of the model are with respect to a tokenization. This one was really important because if we want to produce a very, very accurate estimation of a miner's performance, the best way to do that, if we're working just with language, is actually to use these casual LM logits. which tell us exactly whether or not they did a good job on predicting the next token, rather than having to learn that value from within inside of a collective, taking all of the other embeddings together and combining them into a single tensor, and then learning from that tensor, which adds a lot of noise, and it's sort of uninterpretable. However, it is, that's the real vision for BitTensor, is producing a incentive mechanism where you can just add informational significance to the benchmark without even working on a particular problem. You are working on pure informational addition to the BitTensor ecosystem. So that was what the original vision was, but we've expanded it so that we can be much more precise about what we can validate. And then the third one we're going to demo today is the sequence-to-sequence synapse. And the sequence-to-sequence synapse, you guys are going to be happy to hear about. I think it's really exciting. It's going to allow us to literally do text generation from our miners in the network. So you can query any of them and ask them to generate a sentence given a prompt. So like, hello, my name is Jacob, and then it will complete the sentence up to the length that you want it to complete. And this will make building applications on top of BitTensor a lot easier. So what I mentioned before, Caro's building an OpenAI playground, and this will be something like a front end that you can go to on the web and directly be like, hey, look, I want to generate a sentence, or let's say that we're doing a DALE type of model. We could literally generate an image or from a text prompt, and that would be something that we connect to through what we're calling the Synapse protocol. Everything kind of makes neurological sense. Synapses sit on top of the axon, which is what happens in the brain, and then they're connected to the nucleus of the cell, which is the model, and it's the dendrite which connects with its receptors to the synapses. So everything. I mean, some people have disparaged our neurological analogy, but we like it because we're trying to build a brain on the web. Anyway, so without further ado, I'll just jump right into it so you guys can see, the technical advances we've done. Obviously, these are not released yet. We really want to make this a real smooth transition for BitTensor going forward. So this would be something you guys can play with if you want. It's in our development branch. Go for it. But it's not something that will be on BitTensor for at least a couple of weeks. All right, so if you guys can see my screen, I'm just going to move over to this Jupyter notebook. Just straight demo. If you guys have questions, please just stop me and I can just go in directly. So I'm just going to run through these cells. Obviously, the first ones are just initializing some things, the wallet. We borrow a lot from Hugging Face. We hope to be interoperable with the largest machine learning community in the world. So we built our synapses to actually work directly with some of the APIs that Hugging Face use. So it becomes very easy to build out this type of functionality. I'm going to show you guys how easy that is. So we're going to build a model. Here we go. Just loading it from Hugging Face. There you go. It loaded. And then we're going to build our server. And this is about 30 lines of code here. And in these 30 lines of code, what we've done is set up all of the different entry points. These are called the Synapse entry points that our model can run. So in the future, we'll imagine that miners will actually run many more of these synapses than just 3, but we're demoing just 3 right now to show what can be done. So the first one is a generate function. Currently, this is the only one that miners do. So this is the current BitTensor 1.0 synapse that everyone knows and loves, which we're returning embeddings. And but we've added these 2 extra ones. So the first one is the generate. So it takes inputs and it generates from a model and returns that generation. And this one here is casual LM, which is tell me the direct predictions, the logits of the model with respect to the inputs, not just the last hidden state, which is what we're getting right here. It's quite simple to set up. So you can see we've built our axon. All this code is very familiar to you guys, that if you've taken a look at the code. And then we attach these functions. Now, this is the most explainable way of writing this code. There's more, you could say, efficient ways of writing this code so that you don't have to run the model multiple times per query. But right now, this is just, I think, hopefully this is easy to understand. So this is our gRPC server, the Axon, and it's attached a number of synapses. These are the different functions that can be called by a dendrite. So let's run that cell. All right, it's already been run. Yeah, let's run it again. So it's serving locally. This is what happens when you start up a miner. Obviously, it's got our wallet attached, and it's started. And what we're going to do here is we're going to query the network, right? So what I've done here is just created an endpoint. This points to this axon. We've tokenized hello, my name is, and that's going to be the prompt to these synapses. So the way it works now is the dendrites, in addition to having the normal standard functionality that we've all used before, we can also send these synapses, and these synapses are essentially arguments. They're proto arguments that are actually passed over the wire to determine how the miner is going to run a call on the endpoint. So I'm actually just going to make this code. It's very easy. You can see, create the dendrite. Here are the synapses we're calling. This is the sequence to sequence generation. I want to generate 40 characters. And who do I want to send to? The endpoints I've made up here. The inputs are hello, my name is, and the synapses are the functions that need to be called. So it's, the nice thing here is that you can load more than one function call into a single request. And that allows us to do a lot of optimization on the miners. You don't have to send the requests over multiple times. Very useful. And there's something else here that I think that I need to point out is that because we've built these adapters, you could say these like synapse adapters, we can build a lot more serialization serialization compression into the way that the tensors are moved on the wire. For instance, in casual LM, we only need to know what your top logits are in order to get a good approximation of how well you've done in terms of performance in predicting the next characters in the sentence. And because of that, because we have that compression, we can actually ask the text casual LM to return only those top K logits. So we can compress the amount of bytes that come on the wire by up to a factor of 512. So that's substantially faster than what it would be for raw embeddings. We can do the same thing for embeddings. We can take a compression of those embeddings, taking just the top logits in terms of magnitude, and still get a lot of the performance that we would get from sending all 1024 while compressing that into a space that's much smaller. And this will drastically increase the throughput of bit tensors so that we can move maybe 10 or 15 times as many requests on the wire per second, making the miner's job a little bit more difficult to do that computation, but also servicing more for the clients and the validator's ability to learn quickly. So I'm going to run this request. Hopefully there's no error. There you go. So we've made the request, and you can see we made 3 forward requests, the 3 axon requests, and 3 dendrites. So these are the 3 types of responses that come back. And you can see we've actually, because we're doing text casual LM, the tensor back on the wire is quite huge. But because we've done this in encoding using top K, it took the same amount of time as the other requests. So it was incredibly fast, and it took up very little bandwidth. So what did we get back in response? So these are the responses, and these are tensors which reflect all of the different types of calls that we asked the model to perform. So we wanted to have a generation call tensor response, we wanted to have a last hidden state tensor response, and we wanted to have the logits. And that's what we have here. So the first one in this list is the embeddings. This is the normal bit tensor embeddings, the most informationally quote unquote significant. The second was text casual M. These are the logit values directly. These are the predictions of the next token given the inputs. And finally, the cool one here is this is the literal generation. This is going from hello, my name is to what the output of the model thinks. So running that down here, you can actually see it says, hello, my name is John. I'm a student at the University of California, Berkeley. And I'm a student at the University of California, Berkeley. I'm a student at the University of California, Berkeley, which is not the most impressive result from GPT. But, you know, it's a little bit autistic and but you can get some really funny results. And what I'm going to just go back to the other screen here and kind of close that down because that's the end of the demo, unless anybody has any questions. Just kind of talk a little bit about what this all means for the long-term BitTensor.
I have two questions.
Yeah, please.
First, you mentioned casual LM. I think you meant causal LM, unless your language model is actually casually responding back that it's a student at Berkeley.
Well, I mean, yeah, it is casual. I
Very
mean,
casual.
so
It's chill. It's no worries.
did I say casual? That's funny.
Yeah,
Uh,
Yes.
twice.
I'm trying to play it casual, guys. Maybe that's just, you know, some sort of Freudian slip there.
Yeah. My other
We're gonna have a
question
lot.
is,
Yeah, yeah, please.
I wanted to clarify with the community. Maybe I think you or Eugene are probably much better people to clarify this than me. How come the model is responding like this? Why isn't it responding better? Isn't it pre-trained?
I can take that. Mainly because the prompt was so short.
Okay.
Essentially, after a certain amount of tokens, the model kind of enters a fixed point, basically,
Mhm.
and then it just takes the previous prompts and then tries to generate again, and so therefore, it gets to saying the same thing over and over and over again.
I see. Okay. Okay. Sounds good. Thank you.
Yeah. What was that great prompt that we had before? The quick brown fox jumped over the.
Lazy
I think
dog.
it was this quick brown fox jumped. I think that was it. I can't remember if it's
What did we get? What did we get on the output of that? It was really funny. We got the quick brown fox jumped up and down on the ground, and the fox was so happy that he was able to get up and walk away. I'm sorry, I'm not happy. Oh,
As BitTensor's already unhappy.
along with that's just hilarious. Would anybody else like to prompt so we can just out of curiosity? Feel
And
free to put
walked into the what?
Okay, sure. The man walked into the. Let's see what we get here. What's going to be very cool is the ability to send this request to all 1,400 miners. So,
That's pretty crazy.
for some reason, GPT-2 is a nice guy that's very apologetic. So the response to yours was, Ella, the man walked into the room and said, I'm sorry, I'm sorry, I'm sorry, I'm really sorry, I'm sorry, I'm sorry, I'm sorry.
A little scary.
It's depressing, isn't it? So these are literally just the generations from GPT-2. So this has got nothing to do with the protocol at all. This has got everything to do with just that pre-trained model.
That's just a model.
In practice, we'll have GPT, Neo on the network. We'll have GPT-2. We'll have BART. We'll have BERT. We'll have all of the many BERT models that you guys know and love, and we'll be able to generate from all at the same time. All 4,000 miners, just get me 4,000 potential outputs of this, and hypothetically, you could have BitTensor talk to itself with feeding the text inputs from one into the next, and just see what it produces, the continuous and endless stream of text. I think that would be quite hilarious to present, at least as an initial thing for BitTensor in terms of an app. The endless I'm sorries between BitTensor models. And that's basically it. I mean, I hope you guys enjoyed that and are excited to see what we can do with synapses. This isn't the end. This is just really the beginning of us opening up BitTensor into multiple mechanisms, multiple applications that it can perform, right? Right now, it's the simplest, most narrow band machine learning system, machine learning neural internet, as you like to call it, in the world. But eventually, it's going to be the go-to for all of these different types of problems. Cool. Please let me know, guys, if you have any questions. Is there questions in your channel? Yeah, Talent
Anyone?
Ventures typing something. We're just talking to the channel guys. Like it's an open meeting. Karen, maybe you have something to say on this. Hopefully you're stoked as us about what this means for the JS library.
Yeah, it's going to allow a lot of new projects and applications to be built on top of BitTensor. So if we think about what it's going to do, if we want to speculate, right? Uh, the I would argue that this is going to allow for a lot more people to utilize the network, and having it go through the validator, right? Builds is good for the I guess what is that called, tokenomics, where you know you could, like, theoretically, right, like a validator could be set up and then people could pay X amount of tau per request, and then that goes towards the validator to be able to service more of these synapse requests. So I think it would be, it gives tau more utility within the network, which is pretty good,
Yes,
practically
exactly.
speaking, from a user endpoint.
Exactly. They allow us to build adapters to make the system act almost in the same way that OpenAI has, from its front end, the OpenAI API. If you can see their examples, right? We have a very similar structure to what they have. And we're just building the incentivization layer on top of that protocol, and allowing our amazing miners to figure out how to do that better and more effectively. One thing that we really want to make sure, though, is that by creating this differentiation of the problems that the miners are solving, and then building validation on top of that, that we don't bifurcate the network, right? So the goal of all the miners should still remain to be producing general knowledge, and it shouldn't narrow down what people can contribute to the system. So if you're just going to be contributing in, say, a narrow band understanding of a particular type of language, you're still going to be rewarded on BitTensor.
Yeah, I foresee groups like Luther and Lion, you know, as they're, training their networks, right? Being not only a part of BitTensor, right, but once it's actually served, right, they could have their own validator portal that, they could like that users could interface through, right? But the greatest thing about it is that if you want to train a fine-tuned version of it, right, that's completely still open. So it gives people who want to build applications, like build models and then build applications for those models, a way to do it. But also, if you want to fine tune that model, you can.
Exactly. Yeah. If you want to do the harder route of fine tuning and extracting knowledge directly as embeddings, or if you just want to use BitTensor directly, if you just want to talk and get "I'm sorry" messages from GPT-2, that's all within side of the protocol. If we do bifurcate, we can also create subnetworks within inside BitTensor where, okay, in this network they're just doing embeddings, in this network they're doing something, maybe embeddings plus generation. All these things can be tested as all of these things can be put into their own incentive mechanisms. And something I was talking about at the beginning of the call is we have a lot of versatility. That was the word I was looking for. We have a lot of versatility in the validators. They can go in many different directions, and therefore we can expand the way that they validate, to not just be limited to embeddings or training a single type of model. One of the best things about BitTensor, in my opinion, is the versatility, the fact that we can train any type of model on any type of hardware, anywhere in the world, and we can validate any type of information as long as it falls underneath the metric of information. Cool, guys. ETA on Synapse update. I think that this is going to be. What do you think, Eugene? Like, clean and polished and ready to go, and we're happy with it. And let's do a conservative estimate. Like, what, in 2 weeks?
2 weeks. Yeah, a couple of weeks, I would say, to a month. I think that's like, if
Yeah, just to be conservative. We don't overpromise. I mean, yeah, Al and I are going to San Francisco next week. for sorry to dox you, Allah.
Thank you. Sorry,
Again, it's just you'll be able to find him. It's a guy from Middle East somewhere in San Francisco.
Yeah,
Anyways,
brown guy in San Francisco. That's gonna be easy to find me. Good luck.
yeah. But we don't want to promise it'll be done next week because there's still a lot of work to be done, and I don't think this is something that we need to rush out the door. Like we want to get it to be really good. Also, Tau Innovator says, also in last week's call, you mentioned the need for a gradual reset of miners to prepare. Will this be as simple as something like PMT restart? Yeah, it should. It really should be as simple as re-downloading BitTensor and then downloading BitTensor, reinstalling, so getting the latest branch, and then restarting your PM2. Like one of the nice things here is that like even the model weights don't need to be reset. These are all language models that can be run within the Synapse protocol. So if you had a a model that's been training for a long time, it will just be a reset. But one thing is that it will probably affect the way that the validators are performing validation. So you'll see pretty quick change in the way that the miners are being evaluated. Yeah, you're welcome. Thanks, Town Innovator. There is maybe some downsides, and it's important to talk about them. One of the downsides is that because we're going to be asking the models to produce other types of tensors and perform a lot more work, we require them to be much more sophisticatedly written. Most of the Hugging Face models just fall right into this category. They can all do casual LM, causal LM. They can do causal LM, and they can do sequence to sequence. But if you're writing your own model, let's say, it would be more difficult to very easily get all of that functionality without probably following along with the Hugging Face style and structure, which is maybe a limitation. And I think it makes it harder to be a miner and innovate. And I think that's something we can just be front face about. Is there a live call now, or is this the right place? Yeah, I mean, by live, do you mean if you can just come into the call and speak? If you think Niall
is not in the general voice channel.
He's not even in. So yeah. Great, guys. Well, is there anyone else? Maybe we'll wait for Niall to jump in here. Let's see if he or she has anything to add to the conversation. Silence is next to godliness. Absolutely. I'm sure everyone just meditates.
Every time I say something, we'll see.
People come away from the BitTensor TGIF-T with a clean state of mind. Yeah, please ask away, guys, if you have any specific questions about what causal LM is, what generation can do, how we're going to use this. Oh, no, it looks like you're presenting. Should we watch the stream? How much more processing power will models need when using the synapses? So what we showed you was the most inefficient way of running the synapses because we ran them each as individual functions. But in practice, if you're optimizing your miner, all of those outputs are, well, for the most part, they're all one forward pass. So to get the embeddings, you get the embeddings, that's up to the last hidden layer. Then to get the logits, that's actually just taking those embeddings and projecting to the logits. So those two could be done in a single forward pass. Then for generation, you can take the embeddings, put them into the model, so the model doesn't have to compute the embeddings for the previous sentence. But then it needs to generate the rest of that out. So generation potentially is going to double the computational power required for the miners. However, in terms of bandwidth, it's very small. So generation is the outputs are about the same size as the inputs, except it depends on the sequence length you're using. And so in terms of bandwidth, it's not much at all. Right. Okay, cool. Well, I think if there's nobody questions, there's nobody else typing in the general chat. That was really what we wanted presented. We hope you guys were happy with that. We're really excited about it. I think it's a huge technical advantage for us to have that, and we're going to be able to push a lot into the system.
Paving the way for the AI folks to start using the supply that everyone's generating.
Exactly. Yeah. All right, guys. Well, without further ado, thanks for coming to my TED Talk, and I'll see you next week.
Next week, yeah, we'll do it from San Francisco. Live from San Francisco.
Yeah, exactly.
Cameras on.
Folks,
TEDx.
have a good one.
Yeah. Okay. Ciao, everyone. Good night.